In this video, I'm going to look at the second part of Foerster's 2.1 definition of limit discussion. Foerster gives you two different graphs to look at here, two different sine functions. By the way, if you're putting these in your calculator, make sure your calculator is in radian mode, not degree mode. So I've typed this into my calculator, and he wants you to focus on the point 32 and keep zooming in. He says by a factor of 10. I think on TIs, if you hit the zoom button, it'll zoom in by a factor of 10. It doesn't really have to be exactly by a factor of 10. So anyway, I've put this in my calculator, and you can see here, you get this kind of weird graph. It doesn't look like there's an undefined place in it. There's just like this bump in the graph. But I'm going to zoom in on the point 32. And I think you're going to see that near that point, things are not maybe what they appear to be on the surface. So we can see a little bit closer here. Oh, the graph kind of goes down, and then it does this kind of squiggly thing. And if we zoom in again, you can do this 2 or 3 times. So you want to be close to the point 32. Doesn't have to be exact, but it should probably be pretty close. Okay, so if we zoom in here, you can see the graph kind of goes up and down and up and down. It gets really small and it gets bigger again. Now, by the way, it looks like there's a gap in there. I believe that's actually just bad graphics. These are really clunky graphics on the graphing calculator, and I don't think you're actually going to be able to see a gap in here. Let's try to zoom one more time. This could be too far, I suppose, but it's worth a shot, right? Okay, if we zoom in here, you can see graph goes up and down and up and down. It gets smaller and smaller, and then it comes back out. And the question is this function approaching a limit? Well, remember, if it's approaching a limit, that means it's approaching a particular y value, okay? Let's go look at the table, because I think that may give us some insight as well. So we're going to look at an x value of 3 and see what the table's doing. We'll make the change in the table about 0.1. So here we go. So at 2.7, 2.8, 2.9, we're getting values that are pretty close to 2 there. Okay. Meanwhile, if we come back toward 3 from numbers that are bigger than it, 3.3, 3.2, 3.1, notice again, we've got numbers that are pretty close to 2 before we have that error where there's a divide by 0 in the denominator of that sign statement that's causing that error. Okay. Let's make the step a little smaller, and let's see what we can get there. So notice once again, we're getting values very, very, very close to 2 in the y position coming from x values less than 3. If we come from x values greater than 3, notice that we're also getting closer and closer to y values of 2. And let's try this one more time. Let's have a really small step here. And again, you can see we're getting really, really close to a value of 2 here, and really close to a value of 2 there. So remember, a limit's all about your function approaching a particular y value, and it does seem like we're getting closer and closer and closer to that y value. Now let me look at a Desmos graph here real quick. Here's a Desmos graph of the same function. It looks a little better on Desmos than it does on your graphing calculator. And that's the point 3.2. Okay, you can see there we've got a y value of 2. Notice your y values are coming in, getting closer and closer to 2, coming from both directions, getting closer and closer to 2, and you have almost that perfect point right there in the middle at the point 3.2. So the function values, you can kind of see there on the table that those function values just keep getting closer and closer and closer to 2. All right? Now Foerster gives us a second function. It's very similar to the first one, but he takes out that x minus 3, and so I'm briefly going to make that change in my graphing calculator. And let's see if I can fire up that graph and get it to work. I'm going to go back to a standard zoom here, 6 zoom standard. And we get a graph that looks something kind of like this. So graph kind of dips down a little bit, then goes up, down, and then goes off. That's not real obvious what's going on here. So let's try to zoom again. We'll zoom in. And he wants us to look at that same point 3.2. So I'll scroll over to about 3.2, and we'll take a look at it. Sorry, video got interrupted. Picking up where we left off. It's a little hard to tell here exactly what's happening. I'm going to try zooming again and seeing what happens. Okay, so get pretty close to the point 3.2 and try to zoom again. And now it may be real confusing. By the way, there looks like there's a gap there, but I believe that's just a flaw in the graphing calculator program. I think the graph is too steep for it to, with the pixel count it has, to really handle this very well. So let's take a look over at Desmos, because I think this is, well, actually, let's check the table real quick here. So if we look at values near an x value of 3, let's look at like 0.1, and let's see if the function is getting close to a particular value at 3. So here we're getting close to 2.9, then 2.54. That's interesting. So is it getting closer to 2? Maybe. It does look like it's dropping down. Our y values here are dropping down. Here, though, these y values don't look very much like 2. I mean, maybe it's getting closer to 2, but that doesn't really look very much like it. Let's get a little smaller step here and see if we can get something more precise. Okay, notice here, as we're getting very close to an x value of 3, the y values here look like they're getting close to maybe 2.5 on this side. On this side, they look like they're getting close to maybe like 1.5. That doesn't really look like we're coming to the same y value from both the left and right side of that point. Let's try something else, 0.001, and see. Okay, same kind of thing here. Look, coming from points less than 3, and then coming from points greater than 3, we're getting 2 values there on either side of that error that are really unrelated. Let's go over here and try to see what's going on with this. So here's Desmos. That's our previous graph. Okay, so here's what the graph actually looks like if you zoom in. I'll zoom out just a little bit. So there's that kind of squiggly thing in there that happened on the graphing calculator. And here's what happens. As you continue to zoom in, this is a graph that goes way up and way down. But as you keep zooming, you're basically going to end up having this graph that goes up and down and up and down and up and down, but it's getting closer and closer together as you go toward the center, but it still goes way up above 3 or above a y value of 2 and way down. And so even as you zoom in, you can see here, there's no particular y value that this looks like it's approaching. It looks like it goes through tons of y values because the curve is getting even tighter and tighter. By the way, what it's really doing, and I think it's hard to see in anything, it's basically going up and down slowly and then more and more quickly over time is really what it's doing, and then more slowly again. Okay, it's doing something like that, but it gets really tight in the middle and much tighter, like infinitely tight. Like the more you zoom, the more up and downs you see. Okay, but it doesn't look like there's any particular y value that's being approached. Okay, and this function we would say does not have a limit as x approaches 3. Okay, when you looked at the table, it didn't look like it was going to the same value. When you look at the graph, it doesn't look like it's going to the same value. So again, for a function to have a limit, we really need to have a y value that as you approach the x, both from values less than the x and greater than the x, or from the left and from the right, the function should be getting close to some particular y value. If it's not, your function doesn't have a limit.